Welcome to this video on managing scale with risk-based testing. My name is Michael Felderer, and in this video we address the following three questions. How can aspects of scale be controlled with risk-based testing? How can risk assessment be performed for testing purposes? And how does a risk-based testing strategy look like? As we learned in previous lectures, large-scale systems pose many challenges to testing. In particular, large-scale systems increase complexity of testing due to many and large distributed and interconnected systems and components, speed of testing due to continuous change and maintenance in large-scale systems, and finally the need for knowledge sharing and alignment between distributed teams in a heterogeneous tool landscape. However, the resources in terms of budget, personnel and time are ever limited, and large-scale systems are used in critical domains. Therefore, approaches that help to allocate testing resources, increase the effectiveness of testing, and provide decision support for the management are needed for large-scale software testing. Risk-based testing can provide this, but what is risk-based testing? Risk-based testing makes a risk assessment explicit and considers risks of the software or even large-scale software system, as in this course, to support decisions in all phases of testing. These phases are test planning, design, implementation, execution, and evaluation, as you can see on this slide. For instance, one activity that can be controlled is how to prioritize tests or decide what to automate first. Two parts are essential and further considered in this video: how to assess risks and how to control testing activities based on risks in a so-called risk-based test strategy. Let's first start with the notion of risk at all in software testing, and therefore with the potential that risk has. Risk-based testing can provide several benefits to testing large-scale systems. First, it can improve test effectiveness to control complexity, which enables detection of additional defects, earlier detection of critical defects, and increased defect detection rates of single tests. Then it can improve efficiency to control speed of testing, which enables reduction of testing time, reduction of testing budget, and earlier release date. And finally, it can provide organizational support to manage test knowledge, which enables knowledge sharing, improved decision support, and compliance to standards. Now, finally, let's come to the concept of risk in testing. Before we can assess risk, we first have to define the concept of risk. In general, risk is a factor that could result in future negative consequences and is usually expressed by its likelihood and impact. The resulting risk value, or the combination of probability and impact, is assigned to so-called risk items. In the context of software testing, a risk item is anything of value. We also call it an asset, and this can, for instance, be a feature, a component, or a fault. In software testing, the probability is typically determined by the probability that a defect assigned to risk occurs, and the impact is determined by the cost or severity of a defect if it causes a failure in operation. The estimation of the risk item's probability typically relies on technical metrics like defects in the past, the change rate, the complexity, or technology maturity or experience, especially in the context of large-scale systems. And the estimation of the impact typically relies on business metrics like revenues assigned to a component, importance for customer, or cost of failure. The first step for risk assessment is to actually define risk items. Risk items are basic elements of a large-scale systems that can be associated with a risk for testing purposes. Risk items are typically, as mentioned before, components or features, and they are derived normally from the functional structure of the system. The second step is then the probability estimation. The probability value expresses the likelihoods of the effectiveness of a risk item. That means the likelihoods that a fault exists in a specific product component due to an error in a previous development phase that may lead to a failure. In the example, we can see a probability estimation that calculates the likelihood as the weighted mean of the defects and their severity observed in the past. Then we calculate the estimation of the impact, and this is done as follows. Impact values are express the consequence of risk items being defective. That means the negative effect that the defect in a specific component has on the user or customer and ultimately on the company's business success. Several influence factors can be identified and weighted according to their importance. In the example, the 5 factors: market Europe, market US, market Asia, certification, and hardware design are considered to compute the component's impact as weighted mean. Then, based on the probability and the impact, we compute the risk values. Risk values are the product of the probability and the impact value. Aggregating the available information to a single risk value per risk item is one possibility and allows already to prioritize risk items for testing purposes. In addition, however, probability and impact dimensions can also be kept separated. Then, this separated information can be used to define risk levels. Risk levels are a further level of aggregation. The purpose of distinguishing different risk levels, for instance, based on a 2x2 matrix for probability and impact values, is to define classes of risks, such as that all risk items are associated to a particular class or are considered equally risky. For special cases, one has to decide to which risk level they belong. So risk areas do not need to be rectangular, but meaningful clusters, as we can see in the example. Each risk item gets a risk level assigned. As a consequence, all risk items of the same class are subject to the same intensity of quality assurance and test measures as part of a risk-based test strategy. And so we finally come to the definition of the risk-based test strategy based on the risk levels that were assigned before. A test strategy describes how testing is organized and performed for each risk level. As input, we have the components and their risk levels, as well as the quality assurance techniques like unit testing or even specific test design techniques and their intensities. In the risk-based testing strategy, risk items are mapped to quality assurance measures via the risk levels. Distinguishing different risk levels allows to perform testing with different rigorousness in order to adequately address the expected risks. This can either be achieved by applying specific testing techniques, like even model-based testing, or by applying these techniques with more or less intensity according to the different criteria like coverage. The risk-based testing strategy should finally be refined for specific risk items, as they may require a special test treatment. That's it. I hope this video gave you a first impression of risk-based testing and helps you to apply it to large-scale software testing. Thanks a lot.